world of engineers. Myself, Dattu Patel, Assistant Professor from LJ Institute of Engineering and Technology. In this semester, I will teach you the subject Mathematics 1. Firstly, what is mathematics? In a simple word, mathematics is the science that deals with the logic of shapes, quantity and arrangement. With the help of mathematics, we can develop intellectual maturity. As you have taken admission in engineering, you might be little bit curious why we are going to study about mathematics in engineering. Let's take a tour why, where and when mathematics is used in engineering. Today's session we are going to discuss about brief introductory session of our syllabus, which is Mathematics 1. In this particular subject, basically there are total 6 units. Let's look at the first unit is matrices. You all are aware about the matrices, which is already studied in 12th science. Firstly, what is matrix? Matrix is the rectangular arrangement of the numbers, expression and symbols in the number of rows and columns. There are the various applications of the matrices. Let's look at the applications of the matrices. Firstly, image processing. Basically, images are represented as matrices, and every element of the images which is called as a pixel. Suppose we have any blur image, and with the help of image reconstruction we can convert it to in original image. Second application is cryptography. With the help of matrices we can encoding and decoding our secret code. This type of technique we can use in defense to our secure code to transform the one place to another place. Next, let's look at our next upcoming unit, which is partial differentiation. Now, in this particular unit, we are going to discuss about limit, continuity, differentiability with the multivariable function. You all are already aware about the single variable, limit, continuity and differentiability of the single variable function. Nowadays we are going to discuss about multivariable functions of the limit, continuity and differentiability. We are also going to discuss about chain rule, partial gradient, directional derivative, tangent plane, normal line and various applications of the partial differentiation. Let's look at the applications of the partial differentiation. With the help of partial, here graphical representation of the multivariable function. In this graphical representation, this one is a 3-dimensional graph. Now, with the help of partial differentiation, we can also find the maximum value and minimum value of the function. In this graphical representation, top peak which is indicated by the maximum value and bottom peak which is indicated by the minimum value. Now, with the help of partial differentiation, we can also find the tangent plane and normal line to the surface. Now, let's have a look at our next upcoming unit, Unit 3. Let's see the contents of the Unit 3, which is sequence and series. Now, you all are aware about the finite sequence and finite series, which is already learned in 11th-12th science. Nowadays, we will expand it to infinite sequence and infinite series. Also, we can find the limit and its sum. Also, we will study about the geometric series, then comparison test, D-Albert ratio test, root test, etc. We can also study power series. Now, if we have a function which is differentiable, then we will use special types of power series like as Taylor series and Maclaurin series. With the help of Taylor series and Maclaurin series, we will find the approximate value of the function at particular point. We all are aware about value of tan 45, that is 1. Now, suppose in university exam or any faculty can you ask find the value of tan 44 degree, sin 44 degree, sin 43 degree, then you cannot get the answer without scientific calculation. Then with the help of Taylor series, we can find that particular examples. Now, basically you all are aware about the calculator. Then some of the basic programming of the calculator, that is based on the Taylor series. Now let's see how the sequence is formed. Here in this graphical representation, I am taking the one examples of the bouncing ball and how the sequence is generated. Another example is Taylor series, how the Taylor series is formed. This one is the exponential function and sinusoidal function of the Taylor series. Now let's discuss about the next our unit is unit number 4, that is Fourier series. Firstly, what is Fourier series? Fourier series is nothing but the infinite series representation of the function in terms of sine and cosine term. With the help of Fourier series, we can find the examples of digital signal processing. Now, let's see the contents of the Fourier series. First one is a periodic function, even and odd function, then function having arbitrary periods, half range sine series, half range cosine series, etc. There are various applications of the Fourier series. Basically, how these signals is formed with the help of Fourier series. Here we take basically two applications to generate the waveforms. First one is a sawtooth wave. In this graphical representation, how the sawtooth wave is generated. When you are increasing the number of n, then we can get the exactly shape of the sawtooth wave. Secondly, generation of the square wave. Here, with the help, how the square wave is generated with the help of sinusoidal function. That's in this graphical representation. Now, let's see the next our upcoming units. Unit number 5, that is Indeterminate Form and applications of integral. In this particular unit, we are see the basically Indeterminate Form means L'Hopital rule, improper integral, beta function and its application, gamma function and its application, and various applications of integral. Let's see the application of that particular unit. Firstly, that is the washer method. With the help of washer method, we can find the volume. In this graphical representation, how the washer is worked. Secondly, slicing method. With the help of slicing method, we can find the volume. In this graphical representation, how the slice was generated. Thirdly, shell method. With the help of shell method, we can find the volume. In this graphical representation, how the shell is generated. Now, let's see our last unit, that is multiple integral. You all are familiar about the single variable function of the definite integral, which is integral a to b f of x dx. Nowadays, we are going to discuss about double integral over the general region, Then triple integration over the general result, changing the order of integration, changing into polar coordinates, etc. There are the various application of integral. Basically, with the help of multiple integral, we can find the area and volume. Let's see our graphical representation of the area and volume. Firstly, area. In this graphical representation, with the help of integral, we can find the area. Secondly, volume. With the help of double integration and triple integration, we can find the volume of the given function. Now, lastly, we can discuss about our syllabus weightage. Let's see. Here, unit 1 that is indicated by the 15%, unit 2 20%, unit 3 also 20%, unit 4, unit 5 and unit 6, etc. This is the syllabus weightage of the marks weightage which is asked in university exam paper. Now, if you have any query regarding this topic, then feel free contact me. Thank you so much.